Hello everyone, welcome to our new video of atom. In our previous video on series of an atom we have seen that how Rutherford rearranged the structure of an atom, in which he stated that proton, or positive charge of an atom is not randomly distributed, but were concentrated at the center. This part of an atom is also named as nucleus, and he also stated that electrons revolve around this nucleus in circular orbit. But he was unable to explain that, how can an electron revolve around the nucleus without radiating energy? If you have not watched our previous video on series of atom, I will like to recommend you to go down in the description box, or pinned comment, and click through the link, so that you can have better idea of an atom, and how atom were described previously. And if you are new to our channel, make sure that you support our channel by subscribing, and clicking through that bell icon, so that you will be notified every time, when we post a new video. Till then let us see how Bohr explained the structure of an atom, which happened to be one of the most important structure of an atom. Bohr model of an atom is considered as one of the most important models of an atom throughout the history of atomic physics, because this model of an atom deals with the quantized orbit of an electron in an atom. It introduced the concept of a quantum number to describe atomic states. Bohr's first postulate came straight from the Rutherford planetary model of an atom, and offered nothing new. In his first postulate, Bohr states that the negatively charged electron revolves in a circular orbit about the positive proton. This postulate is quite easy to understand, as it follows the Rutherford model of an atom. Bohr's second postulate states that electrons revolve around the nucleus in fixed orbits, or shells called energy levels, without radiating energy. The above postulates state that every electron revolve around the nucleus in a fixed circular orbit, and the electron cannot revolve somewhere between the two orbits, so they have a fixed path to revolve around the nucleus. Also, when electrons revolve in this orbit they do not radiate energy. Certain orbit in which an electron does not radiate energy, and are stable, is called the stationary orbit. And since each stationary orbit has fixed energy, or quantized energy, therefore, they are also called shell or energy level. These orbits have a specific value of positive integers, starting from the orbit which is closest to the nucleus, that is, 1, 2, 3, 4, and so on. The number of orbitals is also determined by the value of the small letter n, or represented by the letters K for first shell, L for second shell, M for third shell, N for the fourth shell, and so on. This number are also called principal quantum number. And principal quantum number can describes the energy of an electron, and the most probable distance of the electron from the nucleus. For example, electron present in first orbital, or K shell, will have lower amount of energy, comparing to the electron that is present in second orbital or L shell. Similarly, electron present in second orbital, or L shell, will have lower amount of energy, comparing to the electron that is present in third orbital, or M shell. Bohr also stated that, as the value of n increases, the farther will be an electron from the nucleus, the larger the size of the orbit will be, and therefore the atom of that particular element will be larger in size. Bohr's third postulate on atom was that, since electrons revolve around the nucleus in a particular orbit, they do not radiate energy by themselves, but when an atom absorbs energy the electron get excited, and jump to higher orbit. In the reverse process the electron returns to the ground state, or to its original orbit, by emitting the same energy it absorbed, while jumping from a lower to higher orbit. This was Bohr's atomic model of an atom, and this model of atom work very well for the atom, which have only one electron, for example, hydrogen atom. But it could not predict the spectra of larger atoms. In these cases, where atoms have multiple electrons, the energy levels were not consistent with what Bohr predicted. Also we does not know yet how many electron does each shell or orbit contain. Does they contain as many electron many as they can hold? Or each shell can contain only a fixed number of electrons? We will see more on this in our upcoming video. But before that, in our next video, we will discuss about one more important subatomic particle, of which we have not discussed till now. Until then, keep watching our video series on atom. And peace learning.